Hello there. Welcome to the archive. Today we will be working on Singalong for Jukebox, which is it's an idea that I want to make work, but the more I think about it, it probably will not work. But here we are. I'm just loading up the biggest level 2 prior right now in a little custom thing here with a bunch of stuff copied out from the priors actually. So we're diving deeper than the sample file. We're diving into the prior files now, and comments here probably justify it. This probably won't work. But yeah, I've been trying a bunch of things. Actual generation happens on this line, I believe. That's actual transformation to the next. It's fed from X, and X is an embedding of the current sample, which is also X, which is coming from the preconditioned transforming. That happens up here in chunks. It's all a bit wacko laid out here in the code, but let's paint it out actually. Paint on that. Let's see. Let's get some line primitives or boxes. Yeah, box. Yes. Let's make sure we don't have anti-aliasing, because that's horrible. Horrible for pixel art at least. So, how do we do this? In Jukebox, we have three sort of levels. Now, here you have level 2, here's level 1, and here's level 0. Level 0 is the longest. It's 4 times bigger than level 1. Level 1 is 4 times big as level 2. Level 1 and level 0 are both classified as upsamplers. Put that there. So, according to the terminology, these two are upsamplers. The actual priors that do these, actually wait, this is bad. The priors, yeah, I need to change this to have a better thing. Yes. So, here are our lists of tokens, and in between them sits the priors. Now, if you want to draw this kind of to memory scale, which I have done for these so far, so actually we can't do it between these and the priors, but the upsampler between level 1 and 0 is smallest basically, and then this one is a bit bigger, and then we have level 2, which is like so. This is a prior Can I get bigger text? Okay, maybe not that big. 22, sure. So that's a prior. This is an upsampler. And this is also an upsampler. Wow. So it goes in this direction when generating from the bottommost prior, which is level 2. So these are the prior numbers. You have prior 2, upsampler 1, and upsampler 0. Now, kind of wacko as well is that these, where the tokens are stored, these empty boxes, which are filled with numbers, they're also labeled as 0, 1, and 2, because they are level 0, level 1, level 2. But categorically, we can basically draw lines between these, like so. So each level has its own upsampler and its own storage of tokens that it works on. We call these T for tokens. Okay? Actually, that's gonna annoy me. So, and what tokens are, they're just integers in this case. And it's the same on this level. And it's the same on this level. Maybe not that big numbers. Oh well. But so these contain the tokens that we are actually generating. These grow bigger over time. The priors are the ones that actually make more tokens. These add more tokens to the end of the list here. And it does that from the level below. Actually, where's my line tool? It does that from the level below. Ah, Jesus. Like so. And this does that too. And this bottommost prior actually also has an input, because all the upsamplers and the bottommost prior are all actually priors, but so they all have the same architecture internally. So you can think of it as off-screen, but in reality it's just randomness. It's just a random noise that it gets fed, and that's what it uses to add variety, I guess, instead of just following what it already has in the tokens. So that's basically randomness. Actually, let's make that random looking by making it wavy. Yes, very wavy. Wavy means it's random. So, this is a top level view of what Jukebox does. This is level 0. This is level 1. This is level 2. Level 2 being the most compressed and most noisy level. Level 0 being the most expanded and most clear sounding level. And then you have the generators that kinda sit in between, but they are actually on the same level because they just push tokens onto here. Oh, and also, I forgot, they also look at the previous They also look at the previous tokens. So something like this as well. So that's the high-level architecture. Now internally, or well, let's just say that this is fine for just doing cuts and all that, because these tokens, one token here at level 0 represents 8 samples. A token here at level 2 represents 128 samples, and they are linearly, it's linear. So you can just take a bunch, cut them in, paste them out, and the vector quantized variable autoencoder will deal with it, because it's the same format, it's the same kind of tokens. You're just cutting and pasting them. You're not interleaving them or anything. If you do that, you will have problems. I've tried. It doesn't work. So, yeah. Now, if you want to do a sing-along kind of thing, what you need to do, or what I want to do, is to give a piece of a song to Jukebox, and then have it generate more. But what it's generated more of, I want it to add in the original song there as well, so that it keeps the original song, but it sings with it, hence sing along. And to do that, if you were just working on this top level, you would have your samples from your original. You would have to encode them. Actually, no, wait. You have your beginning of your song, which is just listens, and then it generates its own. That's all fine. But then when we want to add in our on the part that we generated, we want to add in the original song there too. There, we actually have to take these tokens. Well, in reality, it's these tokens on level 2, and decode them to samples to add them to the original song, and then encode it back in. Because you can't interleave these tokens, and you can't really just add them together, because this is an abstract representation of the samples. You can't just add and subtract them. So, how does a prior work then? How does a prior take these tokens that it takes in from basically bottom and below? How does it work with them? And the answer is, this entire box, this entire picture here is going to be this prior. So in the top corner we'll put prior. This entire thing is just a prior. In a prior, you get your tokens from what you've already generated, and you put them into a embedding. And out of the embedding, like this what comes in here is just sequences of tokens, but for the time being, let's just imagine it's this token that comes in here. This token comes in here into this embedding. This embedding sees, oh, this is token 2451. That means I'm gonna use this list of floats to output. So the embedding outputs a list of floats, which is determined by the token. How do I... Yeah, let's do this. It outputs... I haven't researched this entirely, but I think it's... something like between 0 and 1, I'm not sure. That's partly what we're gonna figure out today. So that outputs a single token, outputs a bunch of floating points. Now it actually does this twice, and it actually takes in a bunch of other things here, two extra things that are the X condition and the Y condition as well. Y condition is from the labels, I believe. X condition is might be time embedding. I haven't researched that. Anyway, the single token outputs a list of floating points. No idea what the range is. No idea how long this thing even is. Maybe I should check that. Huh. But here's the thing. When I've been mucking around with this, it seems like although you can't add these tokens together, you can add these embeddings together, because these embeddings, that's actually what the transformer works on, it seems. So here we have the transformer, the heart of the system, and that takes these lists of floats and outputs another list of floats, I believe. Something like so. Now this is very overly simplified. And then this is then quantized again into a token. Maybe it's I have no idea, but I have no idea how it's done, but it's probably some kind of quantization which creates the next token to output, and that might be 5241. Let's do similar, 3211. Yeah, sure. So that's how the priors work internally. They take these tokens and they expand them into these lists of floats, yes, and then they work on that. And so yeah, these tokens map to arbitrary embeddings, but the embeddings actually have like a sense, a meaning for this transformer. And the quantization and the embedding work in tandem to represent that with the tokens. The token is just an abstract, arbitrary, non-continuous space. It's literally just random what these tokens mean. They're not linearly or exponentially, or there's no clear function to how they're laid out in the sample space. It's just kind of what it encountered and what it learned. So these tokens, you cannot add them, you cannot subtract them, you cannot really interleave them. But these embeddings, you kinda can, I think. So that's what I've been trying to do. Have we stopped yet? Yes, does not exist, is not defined. Yes, that is very much correct, dear sir. That's exactly what I wish to happen. Now, I've been already trying this a bit, and the results have been lackluster. Let's try this one. It's gonna try and sing along to the XX intro. I mean, as you hear, we have some interesting variation. And you actually hear a bit of the original song peeking through-ish. But when the drums kick in, also that high-pitched noise there, yeah, this is sounding less and less like the original, TBH. Maybe it's because I don't have any conditioning on Jukebox. I don't know. What I do know is that it sounds like shit. So, let's go to this part right here. It's done in 2 steps. Once for priming, and that's when it listens back to what it has before. And then it's... Well, the thing with the transform is that you have a window that you move along. And every time you move the window, you gotta start over with the embedding. But that aside, originally, here's where you actually get the embedding. You get the embedding from X, the X condition, and the Y condition, and to do, yeah, 4 or 2 in my case. That's your that's your N sample size. Sample T is the current sample in the window of 8192, I believe. And that produces X prime and condition prime, which is then put through the transformer, and then yeah, X prime is deleted, I guess. Is condition prime used? Condition prime is used. Maybe. No, it gets deleted. Yeah, I haven't really been able to follow this part entirely, but long and short of it, X enters here, somehow falls through all of this, and then becomes set to XS, the last of XS, which is what it the last of the embedding. Okay. Hold on. Is this priming even... x prime generated here is never used below here. It's only used if it's prediction time. Just don't create x prime, bro. Bro, what the hell? What the hell is that coding? Man, that's inefficient as hell. Or maybe it's maybe I'm missing something. Maybe the transformer actually has like an internal state. Because the transformer is used again down here. And the transformer is... its cache is deleted at the end. I wonder... I don't know. I'm keep it like this for now. But... what I have so far is that I have my code down here, which takes an appropriate section of the original, pads it if needs be, encodes it into tokens, and then passes it along into sample partial window as an extra thing on the end, and then I've overrode sample partial window to be here, takes that inject, passes it along to sample single window takes that and passes it along, appropriately splitting it in batches to sample. Sample again takes the inject and passes it along in primed sample down here, because there is where we will be using it. And then in primed sample, which I finally have up here, there we go. We actually gonna use it. I wanna check this. Yeah. I wanna see if condition is used after all. I never got to do that yesterday. Then I want to maybe try this again, I don't know. I mean, I guess we could try a 50-50. Sure. Now, I guess we run. Go, go, woo! Oh god, we got a slow one. Balls. $14 Vadrian, 15 tokens a second. Oh yeah, I never explained. I'm sorry. So, what I do is, this is my little inject. It does an embedding, just like the original token, but I do it for the injected token, and I add it in proportions to the original. Right now I don't do it for the condition because I'm unsure if add condition after transformer is actually set. Actually, let's see if that was set. False. So yeah, that tells me condition is not used. Whack. Condition is not used. Condition is not used. Here's where that temperature is evaluated, by the way. You know, that temperature of 0.97 or 98 or 1.0 that people have? That's what this does. It just divides X. It just cools down if it's less than 1. Or it hottens it up if it's more than 1. Makes the vectors longer. Makes the system have more energy and therefore hotter. Hence, temperature. But yeah, X is then filtered. No idea what that does. And then it's then here's where the token is made, I guess. I assume. Or maybe it was here already. I need to check X out. GitHub. Yeah, sure. Yeah, there. I'm lazy. Oh. Hmm. But that's for tokens. Hmm. I don't know. Come on. Why can't I include like parentheses when searching? This is awful. Come on. GitHub. Oh. But yeah, somewhere between here and here somewhere, the token is, well, made. It goes from the embedding back to the token. I guess it's the exount. It may be the sample of this categorical distribution of X. Eh? What's filtered logits? Do we even have that? Transformer ops. Ebooks. Transformer ops. There. Filter a distribution of logits using top K and or nucleus top P filtering. Args. Logits. Logits distribution shape. Vocabulary size. Top K. above 0. Keep only top k tokens within the highest top probability. Top p. No wait, less than 0. Yeah. No, top k larger than 0 as an integer. What? And then top p larger as 0 as a float. Okay. Top p, keep the top tokens with cumulative probability above top p. And since top k and top p is always 0, it's just going to be no filtering. Yeah. Whack. What does it do though? Lol, lol, lol. It literally does nothing. It's literally gonna do nothing. Lol. Oh. Yep, it's just gonna return logits. How are you doing? You're doing well. Let's stop it and have it output. See what it got. At a 50-50 adding of original and itself. Let's see what it got. The thing is, it's now just gonna be a straight copy, isn't it? This too is gonna be exactly the same, isn't it? So far, yep. Yeah. Tell you what. Let's see if actually, like, properly... Where are you? Where are you? Where'd you go? There. Let's give this actual conditions. Hip hop rap? What? Bro. I'd rather look at core at this point. Man, that's a toxic site, okay. What? Great. Let's just wing it. Ambient electronic. Sure. So we're gonna try again, but not at 50%, 50-50. We're gonna try at 75-25 like before. That made that weird thing. Go! Ooh, it goes. This is how it is to work with Jukebox. You hit. Oh, we have chats. Any reason you're experimenting with this song sample? No, not really. It's just what I had at the time. I am getting kind of sick with though. And is my name Daniel? No, it's Michael. I do know someone named Daniel though. Let's see, the conditions. Yeah, they're literally never used for this mode. Maybe adding them together is wrong. Maybe I should negate them. Who knows? Before I knew a way to keep a Chrome window on top, I don't realize. I forgot how to do it. God damn it. Yeah, I forgot how to do it. RIP. Let's see what it has. Well, good so far. Both took the exact same route there in the beginning. Yeah, maybe all I needed to do was to actually properly give it conditions for genre and artist. Well, genre in this case, since artist would have been unknown anyway. If you leave a blank, it defaults to unknown. And unknown is the same as various. So yeah, it's a catch-all. But yeah, I'm I'm very much doubtful. It seems that Xout is providing a bunch of possible token predictions, and then the categorical thing here is actually doing the picking one of those. As the token to output, I assume. Yeah, things are. I don't know if I doubt this. I mean, I can't just fix it by properly giving it conditions. The thing is meant to work unconditioned as well and not just fall into whack, which it kinda does. Mm. I'll let it finish this one and then we'll see what I got. See if we'll see those symptoms of that tone appearing and it kind of going quiet or whatever it does. I don't know. It's kind of what I've had from the other ones. They kind of like go quiet and or I, I think it depends. Yeah, it depends on how I had it set up. Hold on. Parents. But yeah, it failure mode tends to vary depending on how I did the blending up here. But it tends to go quiet or have that tone. Maybe I just need to find a balance, or maybe I just need to try and maybe I should add it after transforming instead of before. Maybe that's the issue. Hmm. 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 Yoink. Stop there. Decode to file. Do a refresh. Come on. There you go. Yeah. I'm gonna try to do it after the transformer instead. Which means this is kind of interleaved now. Oh! Actually, this might not work at all. Oh boy. Oh boy. Should I just try straight up adding x2 without anything? This is my god. Well, it runs. Oh my god. This can't be good. But I do believe that doing it after the transformer like this is actually the better thing to do, because then I'm not technically off by one anymore. Woo! Speaking of. Oh yeah, I didn't compensate for that. Yeah, being one sample off shouldn't be an issue. Either way, it's fixed now. Who wants to bet that it's going to go to absolute crap after a single generation? Oh, it outputted a wave file. How convenient. Yep, let's see what it has. It's only gonna be 6 seconds. Okay. How about number 2? Okay. I mean, it's too short for me to determine if there's actually anything wrong with it. Wow. This is a record amount of concurrent viewers for me. Should I go one more after this? I kind of want to get to the part of it where it's the drums. Those. 21 seconds. 21 seconds times 44, 100 divided by 128 is 7,232 tokens. How many do we have? 4,000. Oops. Yeah. So yeah, right now I'm not even adding them in proportion after the transformer. I'm literally just straight up adding it. So it's like 2 times the signal strength, maybe. Might lead to wacky things. I might have to do x divide equal 2 later. Who knows? But we'll test it like that for now. Although, is it an issue though? Because after this, it's just gonna go through. It depends. If that is a network instead of a statistical function, then this might be the loop of the system, because the incoming tokens generate more tokens, and those tokens that were generated are then used to generate even more tokens. This right here might be an excess of energy buildup, heat buildup in the system. The tensors and the values might run away on us and get too long, and then the network's just going to break down because it's not used to dealing with that large values, because it's never seen those large values before during training. Where are we at? 6,400. We need 7,200 at least. Wow. Actually, let's just stop it here and listen to it, see what it has to say. We'll preview before the drums, I guess. Come on. Here you go, 1,024. And stop. And decode. And continue, I guess. For the hell of it. Let's see. I think I need to divide by 2. I think the network is being overheated and breaking down. Not sure. We might find out very quickly once we reach 7,200. Oh, that should be about now. Stop that. Decode. Continue. Let's see. Let's jump forward. I don't know. Is this working? I don't know. It's hard to tell. Like, is it just acting as normal? Or is it actually being affected by my injection? Oh great, I just lost all my hearing on my right side. What the fuck? All I hear is a low tone on my right side right now. And now it's letting up. Hmm. Hmm. Yeah, I'll let it run to 9,000. Decode there, see how it deals with the beat that comes after 7,000. I hope it deals well. The more I think about it, this doing the addition after the transformer should be a more stable solution. Should. Should. Hmm. That depends though. Is the input and the output of the transformer the same format? Or does it shift around the inputs and the meanings? Like, hmm. 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 Yeah. I need to do more research. Hey, look. Output periodic wave. That means I don't have to stop at. Yes. 120. Well, it kinda got it, I guess. Beat starts now. Hmm. That one just seemed to give up. I don't know if it's over temperature though, or if the vectors are too long. I don't know. I simply do not know. I know too little of these functions and systems. I have no idea what X out is, for example. I do know that filtered logits does absolutely nothing though. Hmm. Uh, oh yeah, now I remember. I was able to keep the pop-out chat on top on Linux, but this is Windows, so no pop-out for you. Does this work? Can I just... eh, Sure, kinda works. See what it's got. It definitely like picks up on the beat directly. I guess. I guess. I do not know. It's definitely acting different. Hmm. I wonder. I wonder. I wonder. Hmm. If 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 these where is it? If these if these embeddings actually stay the same before and after, then we should have basically heard it. I have a whack idea actually. I have a whack idea. I want to test skipping out the transformer entirely and instead trying to just set x directly to x2 and see if we get the original back. If we get the original back, that means that the input and output to the transformer is in the same format. If it doesn't, that means it's a different format, I guess. It's very likely that it will be a different format and that we will get an entirely different song. or just whack things, I don't know. Come on. Decode. Mostly interested in up at 0 now. Don't know what to think about that, really. So, with that in mind, let's rename that. Let's modify this to do my little experiment. Let's see what happens. Where is it? Yeah, there. So instead of using the transformer at all, we're just gonna do that. Yeah, this is not gonna go well. It's gonna generate extremely fast though. Well, it's fast. Oh god, imagine if Jukebox was this fast. That would be a godsend. Then it just boom, 1024 tokens. Get wrecked. 3 seconds, boom, 3 seconds, boom. Jesus. Literally 3 times real time. Probably shouldn't go too far though with this. 10,000, sure, one more. It's fairly fast anyway. Yeah, there we go. Whoop. Who wants to bet that we have garbage right now? I'm willing to bet we have garbage right now. This tells me that the input of the transformer and the output of the transformer is not in the same format. So, hello? Yeah, there. So, let's delete both of those because it's invalid. And let's try something else. I mean, I have tried x plus equals x and x plus equals x over 2. And also this thing. Actually, hell, let's just do this again and see what happens now when I have it actually conditioned. Let's see if it acts the same. And we're back to slow jukebox. We can kinda add the embeddings together. But it kinda doesn't work. There's no good way to add it after. Mm. Mm. I don't know. 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 Yeah, it's just a straight copy now. God damn it. I'm gonna keep running it. Maybe that's why I had to divide by 2. I guess. Let's... Yeah, let's try this. And we wait again. But in this configuration, that tone tends to appear, I believe. Okay. Hmm. Maybe I'm slightly off with phasing on the tokens or something like that, which leads to destructive interference, which is why they go silent, and sometimes constructive interference, which is why that noise happens. Maybe? Perhaps? This is straw clutching at its best. Here, look, we got another file. One more segment. Okay. I think I hear them going quieter though, which means it's fighting itself or something. Honestly, I have no idea. Oh yeah, by the way, before, with this and this, I kind of forgot to tell, or maybe I did tell, but I forgot that I did tell. But I at first tried doing the addition on these tokens. Didn't work. I then tried decoding these tokens back to samples, then adding it with the original, and then encoding back the tokens. But that introduced horrible hissing artifacts beyond level 1. So yeah, so that's why I have to try to do this now. And also, now when we have tested, we now know that the embedding and the quantization are not equal in their format. Not equal format-wise. AKA, this token, or this floating point here, does not mean the same thing when it outputs it again for the quantization. The embedding and the quantization are two entirely different systems, which works on different formats or data protocols. It's a few different ways you can see it. But now we know that. So we basically have to take our tokens, the 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 regular way through here, and then get these, and then add it with the these tokens that come through here. We have to do this on this side because the format here is not the same. Anyway, one more. Or what I mean with that is to 1000 and then we'll decode. Okay. Okay. Yeah, no, I'm doing the divide by 2, so 2/3 of the signal is jukebox and 1/3 is the injection, and the entire signal is 1/3 above normal. Or maybe 1/3 above normal at peaks. I still have a feeling that this will not work though, and that it will just be too much like the original. I don't know. Ugh. It might be working. I kinda refuse to believe it until it's actually worked through the entire song and like markantly changed it and not just copied it. Okay, that's a change. Yeah, okay. That almost scared me. But once again, even if it is different, it needs to be sensibly different, because we might be injecting these at entirely the wrong points, and the network might just be what the fuck, mate, and just like just giving us whatever. Because because these networks, they really have no idea. They can't have any idea of what happens outside of their normal domain, because they've never been there. They were never trained there. So it's basically outside operational margins. We might be. We might still be inside. We might be entirely outside them. We might be expanding the input vectors of this thing to such a degree so that it's just being metaphorically shoved into a wall and chooses the wrong tokens because of that. Actually, now when I think about it, the length of the vectors will never get infinitely long, but they are double as long as we kind of want them to be. So there's still possibility of janky output, but the output is tokens, and then the tokens get embedded to normalized embeddings again. So it kind of resets there on each token. It's just internally though, that's not high level volume wise. It may still get stuck into very loud or very quiet sections. That's what I mean with jank output, I guess. Ooh. I don't know. I might have to try this with another better song. Frankly, I'm tired of hearing this song. Now the actual drum beat begins 40 seconds in, something like that. Yeah, 39 seconds in, 40 seconds in. If it does something interesting after 40 seconds, might be a success, might not be. It's just about there. So it's about to start it, but we probably want some more, so probably another 2,000 tokens beyond that. I do kind of wonder what happens if we do start to filter it by the KMP. Hmm. Let's let this one finish and we'll listen to it. Yeah, that's just whack. Need more time. Or need more need more song to determine. There's that tone again, god damn it. I have a stupid idea. I have a stupid idea. Hmm. It's also a question of whether it should be done in the generation or the preconditioning. I don't do it in the preconditioning right now. I only do it in the generation. Maybe it should be other way around. What I wonder is this. What happens if you negate x2? Actually, x equals x2 negative x, yes. What? What do you mean, why shall I move? North Mountain Films official account to... okay. Oh yeah, let's stop that. And let's decode. There's that tone. So adding the X's together doesn't work. Let's see if negating it does work. Yeah, let's just go full out. This may just be a copy of our primer again, or the original, as we say. I'm trying to think of ways to get this to work anyway. But I don't know. How can I do this? Hmm. Yeah, I'd call that broken, indeed. So you can't negate them, really. Should I set these to none, maybe? Hmm. Ooh, ooh, ooh. Maybe I can do it after X out. Ooh, ooh. This is now dangerous. If inject not equal none, x plus equals x2. Ooh, nice. 2 by long by 1. So no, no. Okay, whatever. Anyway, we're gonna try it after the X out now instead. And we are gonna get... Actually, let's do that test again. See if X out actually transforms it back to what it's supposed to be. Like so. And for brevity's sake, I'll do that. And we will now do a little test. We have uncoupled the transformer, and we entirely broke it. Hurrah! you go. Dude, what the hell? Where did that error? What? Okay, it seems to be a different format yet again. Probably still not going to work, but where's our shot? Nope. Yeah. Let's see if we can actually give a condition of none. Doubt it. Yep. Non-type has no attribute shape. X condition needs to be there. At least. Don't know about Y condition. Okay, that works. No Z condition needed. Z conditions is tokens, I believe. And they are time embedded as well, I believe. It's timing information and lyrics in the Z token, in the Z conditions. Do know about the X. Don't know about the X. It might be the lower level. Oh yeah, probably is. Hmm. Hmm. Slightly different. Even one little thing in, so that's good, I guess. I don't know. Hmm. Yeah, I might take a break here soon after this one finishes. And I'll keep working on this offline because it's slow. Okay. If this is the exact same, I'm gonna get angry. Not the exact same. Whoa. But it does kind of follow. Now, all we have to do is hope that it doesn't do that nasty tone or goes quiet. I think it's some kind of phasing issue. I have no actual idea. Maybe I'm a token out of sync. Because of how the transformer works. I don't know. What I do know is that I'll be going and taking a break while this sits and chugs a bit and see what falls out. But yeah. Goodbye. See you next time.